Hey guys, Eddie Alho here with KissAnalog.com. Alright, so today what we're going to do is we're going to do the third in this series on this Class D audio amplifier. It has GaN FETs in it. And what we're going to do today is we're going to look at the distortion, okay, and across the audio spectrum. So what we'll first do is inject a 1 kilohertz signal and see what we get. Harmonics, subharmonics, whatever. And we'll see if the noise floor jumps up. And then what we'll do is I'm going to show you how to actually sweep the signal so we can look across the spectrum and see what it looks like. The first video we looked at the gain phase, kind of a Bode plot, and well, not kind of, it was a Bode plot. And then the second video we used this thermal camera to see how cool things are, because it's pretty cool. Unlike this Class AB that needs this big old heatsink, this guy, 150 watts, no heatsink. So, pretty amazing. We want to look at the noise to see how clean the signal is too. Alright guys, so hey, like the video if you like it, and subscribe if you haven't done so, and let's jump into this thing. Let's bring the camera over and look at the scope, okay? Okay guys, so here's the setup real quick. This meter is looking at the positive voltage coming in from the power supply. It's a split power supply, red positive, blue negative, yellow ground, and this meter is looking at the negative power supply, so I can watch both voltage rails come up. And what we have is our signal coming in here into the RCA connector. We could, you know, maybe I should come in through the XLR connector. I haven't done that yet. For the balanced input. Okay, so I'm coming through the XLR. I've got the oscilloscope probe looking at the input signal, and over here I have a differential probe looking at the output signal. We're just coming through this right channel right here, and this probe right here is a THD meter. It's the Keithley 2015 THD multimeter. It's a really awesome meter, and these white wires are connecting up our two 200 watt ohm resistors, 8 ohms, and I've got another set of differential probes over here on one of the power supplies because I was looking at the voltage ripple. So, and then up there I've got a Handtech current meter looking at the ripple coming from the power supply as well. Alright, and so just to let you know, this is a MixSig DP 10013 differential probe, and this guy over here is the Pintech DP25. Okay, and this is the Pintech. That's what that looks like. It's set at ×20, and the MixSig, it's a little bit smaller unit. It's set at ×50. That's the smallest setting for each one of those diff probes. Let's go look at the oscilloscope. Okay guys, and this is a Keithley THD meter. It's a 2015. It's a multimeter with the THD function. It's really awesome. So I hit the shift key, hit the THD, and it puts in this mode. And it's kind of jumping all over the place because it's automatically trying to find the frequency of a fundamental. And then after that, it filters, it does a bandwidth thing where it filters that frequency out and it measures all the rest of the noise, the harmonics. And when I hit this measure button, it says THD, or I can, and it's frequency auto, and I've got up to 9 harmonics. I can even do more than that. I'll go 19. I don't think it's going to really matter. So I hit enter on that, and then we're going to show percentage, and there's some other settings here. I can do standard deviation, THD plus noise, and but you know what, we'll just do THD for now. You know, I'll tell you what, let's just do THD plus noise. Let's just get the whole deal. THD plus noise. Now it measures everything except for the fundamental frequency. Okay, enter that. Okay, now right now it says there's 2% total noise. And that's because the signal is so low. The 1 kilohertz signal, it's so low that the noise, I think the signal is down around -30 dB, and the noise is down around -40. So comparing the noise to that signal, it's about 2%. Now watch, I'll start bringing the signal up, and you'll see that percentage just drop. Okay, now I'm at 0. Okay, I'm at 0 dB right there. So I got about 0.1 total harmonic distortion, and that's with noise and everything. So now if I go back to just THD, which I think it was nice to see the noise in there, but okay, now let's just do that and then exit out of that. Now it's 0.01. So there's some harmonics in there giving about 0.01, and then there's a little bit of extra noise in there that bumped it up a little bit. And by the way, we're going out to the 19th harmonic, which is around 20 kilohertz. So that's measuring across the whole bandwidth, because the fundamental is at 1 kilohertz. So that's going out there. So that's pretty good measurements, right? Alright guys, so just a little bit of setup with the scope. I've got just 2 channels working right now. Just channel 2 and channel 4. Channel 4 is my oscilloscope. It had that little yellow collar down there on the input. So this is the input, and then this is the output, the mixed sig differential probe. Okay, so the blue one is the output, this is the input. And I've got some measurements down here. It's about 104 volts on the output and about 1.13 on the input. So this is 1 kilohertz. Yeah, it says 1 kilohertz right here, frequency counter. So that's a scope mode, right? Now, when I go to this options button, I go to spectrum analyzer, and my source is going to be channel 2, my output, and there's the thing right there. So frequency span, okay, span is 20 kilohertz almost. It's off just a touch. It says start is 10 hertz, stop is 20 kilohertz. So it's just 10 hertz off from center because of the start being at 10 hertz. So we got 10 hertz over here and then 20K over here. So basically 2K, it's 2K for every grid. So that's 1K. That's our input. Now what I could do is, let's say if I say center 1 kilohertz, if you want to just look at the center, and then span, I could go say, let's see, there's 1 kilohertz right there. So I'll go 2K. Alright, so that's our 1 kilohertz input signal that we're looking at, and it's 0 dB. And over here, that little green marker is showing 1 kilohertz at 0 dB. And you can kind of see the SA, the 0 right there. And bandwidth, I've got that cranked all the way to 5,000. It drops down here to 1,000. Sometimes I get it even lower. Depends on the signal, I guess. But okay, I got that cranked up. Right now, only let me go to 2,000 because of the settings. Okay, so that's 1K and 2K. So now I'm going to go back to 10 hertz. 10. That's what I want right there. So go back and 20K. Come down here, select. Go up to 20K. There we go. So now we're back where we started. Alright, so just had to check those, and there's our 2 kilohertz signal. So right here you can see our green markers kind of up in here, and it says 1K 0 dB. So look at the noise floor. It's way the heck down here. Can't even see it. That's crazy good. And if I bring it up, say plus 10 dB, bringing up the input signal, see that thing crawling? Now look at all the harmonics I get. See this? The signal is going off the screen, so I have to put this, I have to make sure that's inside the screen. And I'm going to put it down here. I'm going to push this center and open this up to kind of fill in the screen. So now if we go back to the spectrum, it should look better. There we go. You can see some see the noise floor right there? That's like 60 dB. 60, that's 60 dB. That's just way down there. Now, if we want to look at that a little bit better, I can go amplitude, and I can go, instead of 10, I can go 20 dB per. So now you can see the noise floor. There's 20, 40, 60 dBs. And I can go up to plus 20 dB now. We can see that spike. Let's go up to there. Okay, now you got to go back to the scope mode again. See, I'm off the screen. So, got to be careful of that when you're doing this. So, you got to get in the screen, otherwise it clips the waveform. Doesn't have to all be in the screen. It actually can go off a little bit, but, you know, I had a little bit too much going off the screen. Okay, now the other thing you'll notice, and I'm not sure what's going on there. The THD meter says 0.09% right now. So the signal is pretty high, plus 20. And so if you come down 20, 40, 60, that's 60 dBs from the signal. That's pretty darn low, guys. Now, when you go to the AWG button, output setup, see, here's my generator 1, output's on, low phase, all that stuff. Here's generator setup, waveform sine. I can pick those guys. So waveform settings, amplitude's at 1.68, that's peak to peak. 1 kilohertz offset. Okay, it's pretty amazing, right? Okay, now what I want to show you is something even cooler, I think. Let's go to sweep mode. And we're going to turn sweep on. And we're going to go linear. We're going to start off at 20 hertz. Look, it's already starting to sweep. And we'll stop at 20K. Page 2. And we'll do it in 10 seconds. Actually, yeah. You know what? I'm going to go, well, I think that's as slow as I can go, actually, maybe. Yeah, I think that's as slow as it'll let me go at that frequency. Now look at that. Okay, now here's the frequency. It's pretty neat, huh? Now the reason it's wider instead of that narrow spike, it hasn't sat there long enough for the scope to take enough measurements to refine the measurement. So we end up getting kind of a wider looking pulse. But look at that guy. Yeah, that's interesting. You know what? We'll have to look at the input signal and see if that's coming from the input. But anyway, look at the noise floor. And there is something there, and that looks suspicious the way it tracks along with this guy, because I don't see a number of harmonics. I see kind of that one guy, and he kind of grows as he goes across the frequency band. It looks a little bit suspicious to me. Noise floor is really low. It looks really clean, other than this guy, that little bump right there. Those things look kind of suspicious, I think. Okay, so this is 20K. Each one of these are 10 or 2K, right? So when this guy is right, well, hold on a sec. Okay, when this guy is right about here, we see this spike here. So that's about 4 kilohertz. So I'll tell you what. Let's go back to the frequency generator and set up. And let's go to, well, let's turn sweep off. Okay, and then we're going to go to frequency, and we're going to just set it to 4 kilohertz. Yeah, see how narrow it gets when it has time? Now look, there's that signal. It's real narrow now, but it is there. That's interesting. Okay, now what we're going to do is do something else cool that the scope lets you do. You can go to this search thing, say search, and we're going to search for peaks. And I can set my threshold. See that line right there that appears? I can come down here. Look, there's another one right there. So if I set it above the noise floor, it's going to see those 3 peaks. And right now it says it's just capturing 1. So let's go to 3. See the markers up here that appeared? Okay, so let's go to peak table, and let's turn this table on. And, okay, 4 kilohertz, we're at 19 dB. And at 2K, we're at minus 37, so minus 40. So that's, like I say, about 60 dB down. So there's some separation there, guys. And then the next one is at minus 21. So it's about 40 dBs, which is still pretty far, but they're there. Let's find out where they're coming from. Turn off the table. Okay, I'm going to move the probe over to the input. I'll be right back. Alright, so I do have a probe with the input. What am I thinking? All I have to do is switch over to the scope probe. Okay, let's go source 2. Let's go to source channel 4. Okay, there it is. Wow, look, there is a little bit of a spike here and here. So see, they're coming from the input. So that's good to see that. Well, okay, so they are coming from the input. The input is around 0 dB. Remember when we were looking at voltage mode, it was about 1 volt. So they are coming from the input. If we go back to scope mode, here, let me just push this guy and center it, and I'm going to amplify it, bring it up a little bit so we can see more of the waveform. And I'm going to capture more waveforms. I don't know if that makes a difference. Let's go look. Yeah, I think that did kind of, look at that. I still see a little spike here. It's smaller, and so you know what? The signal to noise ratio, because I didn't have enough amplitude. Let me explain something real quick about the scopes. If you have an 8-bit A to D processor, you know, analog to digital guy, and if you're only using part of the screen, you're losing bits. It's like, I think if you're down half the screen, you're down at 6 bits, which is huge. And if you're 3/4 screen, it's like 7 bits, something like that. I have to check that, look it up again, but I just kind of remember something like that. So anyway, whenever you look at the signals, you want the best resolution, blow them up. And adding cycles like that, I'm not sure if it made a difference. Let's see if it did. Let me get fewer cycles and see if that makes a difference. No, it doesn't look like it really changed the measurement. So, but it does make it, I think in spectrum mode, it does its own thing. I don't have to capture all those cycles. In FFT mode, you do. So you got to be careful about that. But yeah, there's a little small signal there now. Okay, now let's go look at the output again and see if they went away. Yeah, see, it amplified this guy, and this guy, there's a little bit of a signal there, so I think it's still kind of there. But alright guys, that's looking pretty clean. My THD meter right now has gone up a little bit. It's saying 0.889. So it actually has gone up a little bit. Okay, now that's also a 20 dB signal. So let me drop the signal down to 0 dB. That's typically where these measurements are taken, and when you're looking at an amplifier catalog, they usually go at 0 dB, which, you know, it's just a comparative place. Maybe they should be doing it at full power, right? I don't know. But, you know, when you go 0 dB, these guys kind of sink down into the mud. Okay, now I'm at 0.03%, guys. So, you know, for comparative measurements, it's 0.03. But even at higher power, at 20 dB signal, that wasn't too bad, I don't think. Hey guys, that was impressive, right? That looked great. So, you know, the first video we saw the gain, the phase gain looked really great across the frequency band. The temperature looked great in the second video. Now we see the noise, it looks great as well. So, hey, let me know what else you'd like to see. I think the next video I'm going to do is I'm going to actually put it into a speaker and play some music. we'll actually put a music signal through this thing, okay? And we'll try that. Let me know what else you guys think, because I got to return this board, but I think I got one more video left in me. So, hope you liked it. Hey, subscribe if you haven't. thumbs up really helps the channel if you like it, okay? And Patreon links below. I appreciate all your support, Patrons. Really like that. And thanks for everybody to watch the video. And we'll see you next time.